Hello, my name is Vince Mazer, and I'm a technical marketing engineer here at Altium. In today's session, I'm going to discuss how to avoid supply chain issues with variants and live BOM part choices. So let me review the agenda. The first thing I'm going to discuss, since this is the overarching topic is the supply chain of electronic components, I'm going to go ahead and review some electronic part supply chain fundamentals. Then I'm going to talk about how design architecture impacts sourcing of components. I'll follow that with how early planning for critical blocks and components can be useful for mitigating these types of situations. I'll talk about tactics for addressing part challenges in current designs or products that are currently being manufactured. I'll then move into the demonstration and we'll summarize. So let's talk about electronic part supply chain fundamentals. So electronic components are foundational, of course, as I'm sure all of you know, to implementing electronic designs to specification. However, the organization that chooses them also inherits characteristics of the parts that are largely outside of their control. Some of these characteristics include availability, cost, life cycle, performance to data sheet, quality, and reliability. And all of these characteristics represents touch points of risk that left unchecked can derail new product introduction and even result in field failures of mature product lines. While some of these risks are unavoidable, many of them can be overcome by employing a more intelligent, active bill of materials and supply chain management process throughout the product development cycle. So I'm going to first introduce some again, this is going to be review for a lot of you, but let's talk about some fundamental definitions. Manufacturer part number, or MPN. This is unique to each manufacturer and unique to each part from that manufacturer. There's no standards on how they can be constructed. It describes the device's characteristics, including type, dimensions, height, temperature, rated voltage, tolerance, packaging. You know the drill. We've all been through this before. I've deconstructed a Murata capacitor part number there on the right, and this is a fairly typical arrangement with all types of electronic components where you have different suffixes and codes embedded in there that mean different things, everything from the value to the packaging, whether cut tape, a reel, a tray, etc. Now the supplier part number is different. It's determined by the supplier of the component, and as with the MPN, there's no supplier part numbering standards. Suppliers determine their own supplier part numbers based on their specific needs. Typically, there are many supplier part numbers for a given MPN. So if you consider, a certain microcontroller, DigiKey is going to have their own supplier part number, Mauser, Avnet, Arrow, etc. And I've got some examples here on the right. Another big part of electronic components is, of course, the electronic component parameters. Components carry data far beyond the part numbers, values, and functions and tolerances. Designers use these parameters as criteria for selecting components. These parameters are used a lot when you're trying to replace or substitute components. And, the nice thing with today's part aggregators, you've got all of this data at your fingertips where you can find just the right component or substitute components in when needed. I've got a little screenshot of a typical data sheet, and again on the right side some of the types of parameters that are typical for electronic components. Now I'm going to talk about life cycles. Electronic components typically progress through 6 product life cycle stages. And this I borrowed this from an IEEE report as cited below the graph here. These life cycle stages are introduction, growth, maturity, decline, phase out, and discontinuance. Now, designers should consider the life cycle of the parts they choose, or they risk releasing designs that can not be produced in the quantity or to the cost or to the specification required. In addition, poor attention to the product lifecycle management of electronic component suppliers can lead to products that are difficult and expensive to maintain throughout their useful product lifecycle. Choosing components that meet the technical mission objectives of the project while also ensuring that they have the appropriate life cycles can provide a competitive advantage that results in winning projects, or products, I should say. While there are published standards that many manufacturers comply with regarding communicating life cycle changes to customers, at the end of the day, every manufacturer has their own approach to defining the life cycles of their products. So referring to this figure, I'm going to review the common component lifecycle status definitions. And again, apologies if this is review to some of you. So pre-release corresponds to the introduction stage of a product. A component in this stage may be new and engineering validation may still be underway. This phase is typically characterized by quote-unquote preliminary data sheets with specifications that can and do change as the product is advanced to the next life cycle. The recommended for new designs life cycle corresponds to the growth stage of a component. The part has been released to the market and the data sheet contains final specifications. Most device vendors will recommend using products at this life cycle for new designs. In volume production, that corresponds to the maturity stage of a component. The component is mature in volume production and likely widely used. The component at this life cycle is typically a solid choice for use, but newer alternatives may exist. The not recommended for new designs life cycle corresponds to the declining stage of a component. This indicates components that are nearing end of life and should not be used for new designs. If newer parts in volume production are available, those would be better to use. End of life corresponds to the phase out stage of a component. Devices at this life cycle will typically soon become obsolete and unavailable from authorized distribution. This life cycle designation should be preceded by a corresponding product discontinuance notice, which we'll discuss shortly, from the component manufacturer. The manufacturer should be contacted to assess any available opportunities to make, say, a last time buy purchase, and to review the time periods for placing final orders and receiving final shipments. Authorized distributors will typically continue to sell the component until the stock is exhausted. It's not uncommon to see this in our supply chain information within Altium Designer be an ActiveBOM, and you'll see that there's an end-of-life component, but there's still plenty of stock available. And then finally, the obsolete life cycle corresponds to the discontinuance stage of a component. These devices are no longer available from the manufacturer or authorized distributors. So manufacturers, I was actually surprised to find this out when I was researching this topic, but product change notifications are designated in a JEDEC standard, and most manufacturers do comply with that. There's a JEDEC standard, JES D46, if you're so compelled to or would desire to research that further. And there are minimum content of these product change notifications. Tracking number, the product identified, detailed description of changes, etc., as you see on the slide here. I've got a screenshot of a microchip product and process chain notification, and end-of-life notifications. You can actually, with these semiconductor vendors, you can register to receive these. And in some cases, you can even register to receive these based on specific parts. Like in the case of microchip, if you're using a specific microcontroller and you're relying upon that, it might be nice to stay in touch with the data that would be coming from that. I mean, the buck stops with the manufacturer. That's where, you know, the closer you get to the manufacturer, the more accurate data you're going to get. I will mention that we provide this life cycle information both in our standard editions of Altium 365 and in the Pro edition. That data is actually curated and provided by IHS Markit. So there's a higher level grade of data that's available in that. But I just wanted to mention that you do have the opportunity to sign up for these directly at the vendor. You know, it's essential to be aware of product changes, particularly those made to larger scale semiconductor devices. For example, situations have occurred where a seemingly innocuous die shrink of a DRAM device made by the manufacturer for margin enhancement resulted in intermittent field failures of released products. This was due to subtle timing differences between the pre and post die shrink devices and the fact that the product design operated near the edge of the timing window. So it's not always about change in stock or change in life cycle, but certainly your device errata, if you will, is going to be conveyed through this, or if there are any other changes. One time I got a product change notice when a particular diode changed manufacturing from one country to another. So that's product change notifications. Now there's also the product discontinuance notices, as I mentioned earlier, and this is issued when component manufacturers make the decision to discontinue manufacturing of a product. They'll typically issue this document and typically issue this PDN in compliance with another joint JEDEC ECIA IPC standard J-STD-048. And, part of this is to provide a 12-month last time buy period when customers may place orders. And there's some information included here as far as what the document should include as far as the minimum information. So that's the product discontinuance notices. Now I'm going to switch gears and we're going to talk about environmental and electronic component and environmental initiatives. We're all familiar with RoHS, as it's commonly called. There have been 3 variants or versions of this as of this presentation, to the best of my knowledge. The RoHS is originated in the European Union. The objective of this directive was to restrict the use of hazardous substances in electrical and electronic equipment and to contribute to the protection of human health and the environmentally sound recovery and disposal of waste electrical and electronic equipment. All applicable products in the EU, I believe this was back around July 1st of 2006, were to comply with this RHS directive. The substances banned under the directive include lead, mercury, cadmium, I believe it's called a hexavalent, chromium, polybromide, biphenyls or polybromide diphenyl ethers. You can see why I didn't take up chemical engineering. But the bottom line is the initiatives are trying to eliminate some of these substances from the supply chain of components and therefore from the disposal chain when that time reaches. Now, our RoHS 1 was recast and entered into RoHS 2, and basically the scope of or the restriction of new substances and exemptions and also coherence with another EU legislation called REACH, which I'll discuss in a couple of seconds, was put into force. And then RoHS 3 was updated. Again, the four phthalates are mainly used as insulation plasticizers and are on the REACH list of substances of very high concern. And these were, they had a category of 11 catch-all products and added 4 new types of substances in rounding out the RoHS 3. So REACH, this is another European Union initiative. It stands for Registration, Evaluation, Authorization, and Restriction of Chemicals. It's like I said, an EU regulation that addresses the product and use of chemical substances along with their potential impacts on human life and the environment. So how does RoHS and REACH relate to each other? Well, they're two different initiatives with different scopes and objectives. RoHS is an electrical and electronic equipment sector-specific directive restricting those certain hazardous substances, while REACH is a general directive regulating registration, evaluation, authorization, and restriction of chemical substances. RoHS does not affect the application of REACH and vice versa. With regard to the restriction of substances and electrical and electronic equipment, when there is an intersection of the two initiatives, the strongest restriction, for example, the lowest maximum concentration, should be applied. So there's another environmental environmental and I guess I should say outside of electronic aspect to components. And this is conflict resources. Conflict resources are natural resources extracted in a conflict zone and sold to perpetuate the fighting. There is both a statistical and anecdotal evidence that accessibility to these precious commodities can prolong conflicts. The most prominent recent example has been the eastern provinces of the Democratic Republic of the Congo, where various armies, rebel groups, and outside actors have profited from mining while contributing to violence and exploitation during wars in the region. So that's the idea behind conflict minerals. Some businesses, some customer bases, some regions of the world require your products to be free of anything that would contain conflict minerals. So this idea of being conflict minerals free may cross paths with your product development plans. So that was a review of the electronic part supply chain fundamentals. So now I'm going to talk about how the architecture of your designs can impact sourcing. So let's go ahead and get into this. Modular flexibility versus cost. I've got a screenshot of a very modular board here. You have some board-to-board connectors. Looks like you have some DRAM modules. The idea is that you can choose to architect your product that way, and that gives you the ability to purchase modules, single board computers, etc., to populate a module board, and you make your product from that. There's obviously an additional cost. Those connectors cost. You might not have as much density as far as what you can pack into your enclosure, but it does give you flexibility that can really come in handy, especially in times like we're in now. Whereas, say, for instance, if you had a module that is a Bluetooth module, and the particular Bluetooth chip you're using is not in stock, very difficult to find. If you had the ability to use in the same physical module, use a different Bluetooth chip, something you could put together real quick, you could mitigate those delays. So I just wanted to talk about this fundamental modular flexibility versus cost. There's also integrated versus discrete. And if you think about it, in a way, those top two, I guess all of these will be related in some way, because we're talking about different levels of abstraction. I mean, it used to be that, designing with transistors, that was it. And then ICs came along. So what I've got here is a Maxim switch. It's a great product. And we've got, for the particular application, an actual discrete implementation that fits the bill for that particular application, which was a voltage measuring circuit, as it turns out here. And this decision can be made at design time, or both implementations could be included on the PCB, subject again to any traces hanging in there unpopulated and how that might impact your design or any type of EMI issues or anything like that. But you could also, you can include both implementations on the PCB, and assembly variants can be chosen at the time of manufacture. But, in this real case right here, and it was just sort of a random device I picked, but this particular part on the left is very difficult to get right now. Costs about $6. The bill of materials cost of the discrete on the right is pennies. And the nice thing about going discrete is you can always substitute. I mean, that was a big deal back in the day, the idea of being able to substitute transistors, and you can do quite well with that. So again, that gives you flexibility. If some of your difficult to find chips happen to be implemented as discrete blocks right now, you might find yourself in a better position to get through manufacturing than some of your competition. And certainly fully aware that you have more placements, you have more soldering, etc. on the right. Again, we all know that our passion for design is an exercise in constant trade-offs. Okay, so let's talk about software versus hardware. This is a little different angle. I mean, the fact is that there are things that you can do in software that eliminate chips on the outside, and there's things that you can do in software to circumvent unavailability of certain devices that you may rely upon. Of course, I cherry-picked a pretty easy one here. This is a real-time clock chip on the top there from NXP, but you could also implement all of that inside of your software, provided you have a nice stable crystal oscillator in there. But again, we're just trying to give an example of how these trade-offs can be made. So it's always nice when you can change things in software to mitigate. We always have to do that with shall I say, deviation from data sheets that we can run into. You can fix those problems in software. But again, something to consider as its impact on the architecture and on product sourcing. And of course, anytime you can do something in software without a hit to overall system throughput, and you can eliminate a device, you're saving BOM cost and insertion assembly cost and such. I just wanted to end this section on BOM cost versus the ability to ship an end product. I mean, there are situations where companies are unable to ship their products, but yet if they had some of this flexibility in there, BOM costs may escalate a bit. Maybe it goes up 10%, but you're at least able to ship your product, because there's nothing worse than having all your design ready to go, customers waiting for your product, and you're unable to manufacture it. So sometimes it makes sense to pay more for your bill of materials if it's going to enable you to get that product to the shipping dock. Now I'm going to go ahead and talk about early planning for critical blocks and components. We all know what selecting components is all about. I mean, I've got a picture here of the manufacturer part search panel. We will probably demonstrate this coming up when we get to the demonstration. But, there's a lot of considerations. You need to take into account the function. In this screenshot here, we're taking into account the fit. You need to take into account, of course, cost, availability. It's a really good idea to use components that your organization is already using. Now, if you're a larger company where you have a component engineering group, you might already have commodity specialists that are working with those vendors. You have components that are tried and true in certain applications, et cetera, et cetera. Good idea to use components that you already have. I know at the beginning of my career when we had these preferred parts and everything that we were sort of back in those days mandated to use, I sort of took issue with that, but I didn't understand all of the aspects that I do now as far as, the quality of the components, the volume buys, and all those types of things. Multiple sources, I mean, that's fundamental. We've known that in our industry for a while. You don't ever want to have just a single source. There's a lot of downside to that, and that should be avoided. Substitutability. I mean, anytime you're able to substitute, and that's what we're finding out, that this current component situation is really calling us to task to be a little more proactive and try to come up with contingency plans. Just in case engineering, if you will. So substitutability is something you'll want to take into account at the beginning of a project. So here's an example. This is actually a real example. You can't ship this particular product without a beeper, okay? It's a cheap part, but that product can't be shipped without it. And in this case, the company that I was working with, you could get a lot of the bottom types of beepers at the time, but you really wanted to use the one at the top where the two leads were in alignment with the little sound port, whereas in the bottom example, they were rotated by 90 degrees. So we came up and we just put this on our board. This wasn't a variant or anything. It was just a footprint. So at assembly time, we were able to accommodate either one. It turned out the pin spacing was identical. The performance was identical. It's just the orientation of the pin wasn't. So that's how we mitigated that. And there are situations today that where this concept might be useful. Along the same lines, again, can't ship a product, especially an intelligent product that has a processor in it without some sort of crystal, if you need crystal accuracy. If you can't get that crystal in the SMT version, this footprint pattern here would give you the ability to put the through-hole version of that component in there. Nobody wants to be, soldering in 1,000 of these, but if you can't get the SMT part, it's going to be better to pay up a little bit to get those soldered in so you can ship your product. Again, consider, this is sort of similar to what I started with in the last section, but, consider modules for lower end product volumes. There's a lot of single board computers or single board, compute platforms, I guess I should say. You have, footprint or interface connectivity across various products, and it's standard in such a way that you can either use this with off-the-shelf mini micro platforms, if you will, or you can even develop your own. And if for some reason you had developed your own and you find that your parts aren't available, you might be able to buy the modules. Again, it's going to cost you more, but we're trying to make sure in this case that we're able to ship our product. So you can start with commercially available and evolve it towards custom. And that's actually used quite a bit. A lot of times companies will use this on new products, and as it gets market acceptance and you want to enhance your margins, you might go ahead and take ownership of putting more of that on your board. So just something to consider, certainly in architectural and planning for critical blocks or components. Another aspect, and we're starting to enter into the area of Altium Designer here, is the idea of using variants. Well, what are variants? It's basically using the same PCB layout with alternative component placements. Now, what I've spoken about primarily before this point has been more of the design side types of decisions you make. Variants are are certainly something you will consider at the design time. What type of situations would you want to accommodate for? But oftentimes these decisions are made just for the different products that you want to come up with in a product line. And so you'll use the same board for multiple products or an entire product family that might have different components populated. A classical example is like, 4 gig RAM as opposed to 8 gig RAM or something like that. So assembly variants, they can include non-fitted components. They can include alternate components, alternate component parameters, and alternate document parameters. And assembly variant information, as we'll see in the demonstration, it flows through everything. When you make a change to a variant definition, that's going to affect your bill of materials, your BOM, or excuse me, your PCB, any type of assembly drawings, etc. This is an example of using assembly variants with alternate footprints. It avoids the need to create a unique version of the design for each configuration. The alternate footprints for the same designator may be placed at the same location. Now this is the variant manager. It's the dialog which allows for the creation, editing, and configuring the visualization settings of the assembly variants. The upper right region displays the components in the original or base version. To the right are the current assembly variants, and each component line item shows the status of non-fitted or alternate component. And the lower region shows the selected component details with the base version to the left, and then details of the component for each of the assembly variants to the right. And then there's controls at the bottom of the dialog. We'll go through that in the demonstration in a bit. To add an assembly variant, you simply click the Add Variant button, and the option to clone selected variant is available on the drop-down menu item. It's at this stage where parameters contained within the entire project can be specified and an alternate value populated. Once the new assembly variant has been created, component actions may be applied to the left of a selected component, whether you want to do fitted, not fitted, or an alternate part. You can also change the drawing options. It will update on the schematic. You can show either an X, or in this case, we're actually using text and the do not load abbreviation. So let's talk about tactics for addressing part challenges in current designs. This is all great, and this might come in useful in the next project, but I've got some issues that I'm dealing with right now that I need some insight and could possibly use any kind of solution. So if you have something like that, that's what this section's about. The key is, just like with any other situation that can cause alarm or whatever, you need early warning of potential problems. I mean, that's one thing one of many things I really like about Altium Designer as a product, is that it's literally supply chain awareness is intrinsic. It's built into the entire product now. So, you get insight when you're placing components. You see that little red bar there. Now, these are components from your library. On any given day, you may look at your components and something you've never had a problem getting, it turns out to be a train wreck as far as availability. You get early insight into that, heads up insight, when you're placing the components from the components panel. You also get this insight when you select a component on the schematic and look at the properties panel. You get this insight, of course, when you're checking your BOM. And let me just go back here for a second. I just want to mention, as we're talking about checking your BOM, those BOM checks can also be kicked off in the project releaser. So when you're generating your documentation for fabrication and manufacturing, you can actually run those checks, and you might find that you have an issue at that time. And the goal of all of these early warning systems in this is to detect issues before it gets to the manufacturer, or as early as possible. You know, another great thing to use, and I'm sure many of you are using it, is the manufacturer part search panel. It's a unified cockpit with all of the information you would need to make a component decision. If there are models available, as indicated by the little chip-like looking dual inline package outline to the right there in the green, you can right-click on that and acquire that. And you can even choose just to acquire the information, the data, the part numbers, and use your existing models. It's just an amazing way to search for parts, and it's basically the same functionality in the same panel when you're actually choosing part choices. So adding part choices is probably one of the biggest things you can do right now to just help smooth things over. And basically a part choice, as indicated here, we've got a 22 picofarad capacitor, and this particular part has a variety of manufacturer part numbers that could populate that position on the board, and your design would work properly. So you almost can't have too many part choices, and this is something that it makes sense to even go through once in a while, or if you have a librarian or whatever, you have key parts, see how these are looking, add more, and then you rank them to your preferences. If you prefer Chemet capacitors, if Vishay capacitors, you know, rank them accordingly. Now, what's really cool is you can edit your components, and you can add part choices to it. And then when anybody goes into a BOM, for instance, that uses any of those parts and it's been updated, the designer is going to get a flag right there in the BOM that you're not using the current revision of the part. So you know, it's one thing to be able to add this at a workspace level. It's another thing to be able to deploy it out to everybody that might use those parts, and we've accommodated for both of those situations. And you can also use the Explorer panel, and you can add part choices very easily in that panel as well. Part choices are key. At this point, I'm going to go into the demonstration, and then we're going to go ahead and wrap up and summarize. So let's go ahead and go into the demonstration. Okay, I'm in Altium Designer now, and the first thing I want to show is the manufacturer part search panel. Go ahead and bring this up here. This is an incredible panel. It's just as the name implies, it allows you to search for any types of components, and it gets this from the you know, what I think of as the component cloud, Altium component cloud. So let's go ahead and just give you an example of what it would look like to look for some capacitors. I can choose that category of component, and then I can come in here and say, you know, key something in. You know, look for 22 nanofarad capacitors. And then what I'm able to do is I could enter in, you know, I could enter in 22 0805. And you see, you know, you can enter in the free-form text. It will give you the various you know, products. You can search by the columns. You can quickly find out you know, what's the most available. That's certainly a good characteristic. You can also do filtering. You can enable that filtering, and then you get these you know, these type of parametric filtering setups that you've seen on many, you know, vendor websites, as far as you know, temperature range, working voltage. You know, I can change this, eliminate what I just typed in, and the whole idea is that this just gives you a great environment to even look for values. Say 1 microfarad capacitor. It will update. what type of dielectric materials. And it's context sensitive in that when you're checking for a transistor, it's going to bring up, HFE and beta and things like that, collector current. And then you've got the information panel here. And as I click on each one of these, I get all of the information right here. I can take a look at, and in this case, again, if we see this symbol here, that means we have the component. And so, you can acquire that to your workspace. And that's how, you look for components. And if you don't have them, you can bring them into your workspace. And such. So let's see, another really neat thing about this, and it's something that I don't use as much as I should, but it's really nice because, when you're at the beginning of, researching components, there's just a lot of trade-offs. You want to see, you might even want to simulate it, but you can literally place right from here. And I go place. And I can actually place this component here. And zoom in on that a little more. So you just place it right from the manufacturer part search panel. You wouldn't want to, you could build a design that way. In my opinion, you wouldn't want to do that. You'd want to have your components stored with your part choices and all that kind of stuff. But this really gets you, off to the ground running pretty quick when you're doing that work. And like I said, with our analog simulation capability, you could bring in a bunch of transistors and such. Next thing you know, you're simulating. So let me go ahead and undo that placement. And the other really neat thing about it is, let me go ahead and bring up some inductors here. I'll bring up my board. And it's loading those inductors. Here we go. And I can actually, this board isn't bare, but if it was, I could actually come in here and place the footprint, and just see how things fit. A lot of times, again, when you're in that, when you're determining what kind of board outline you're going to use, what kind of enclosure you're going to use, what your components are, these types of things are pretty helpful. And then as far as enclosures go, you can actually come in here. I just think this is so useful, especially if you're doing you're at the beginning of a design. Let me find the right component here. I know it's here. You make this a little bigger. I'm going to find an inductor here. Say this guy here. And I can go ahead and even place this. Again, I'm not in the components panel. I'm in and I can place this guy here, and also go ahead and change the orientation of this board a bit and come in here, and I can see better how that's gonna fit. I can place this in here. This is an unrouted board. And I can get an idea of how things are going to fit. And I still haven't even decided on, whether or not I'm going to use this component. So, the thing I wanted to get across is, with the manufacturer part search panel, you're able to filter, you're able to identify components. You can also do that extra due diligence, just like going back into an old data book and just, dragging it right onto a board. I'm just dragged it right off of the component cloud onto the board to see if it would fit. I could very well have it in my enclosure and do my due diligence that way. You can place 2D to see if you have real estate available. I showed you how you can place the 3D. We talked about acquiring the component with the models. And if you want, you can simply, create create components as well. So that's the manufacturer part search panel. That's a mainstay of how to mitigate these supply chain issues, because this is your repository of information, or this intrinsic, empowered information on supply chain that allows you to find components that you can use as part choices and such. So I'm going to switch gears a bit here, and I'm going to be talking variants. We've got a board here, and it's probably most convenient to show this in the 3D mode, but I will go into the 2D, and you'll see some things here. We've got two footprints here for this RAM. We've got a ball grid array, and we have a, I guess it's a SOP part. And then we've got the same here. So ball grid array and more of a conventional SMT part. And then we've actually got two LEDs stacked on top of each other right here, and at a couple of other positions. And because these are variants, there are no design rule errors or anything like that. So let me just show you the variants that we've got set up here. And it's illustrative of what we've been talking about. It's best to show this in 3D. So this is with no variations. On the left side here, I can take a look. If I double click on the blue LEDs, we see that the LED positions are populated with blue LEDs. I'll zoom back out here. And then if I choose not to populate the RAM, we've got a variant for that. And we can also populate the ball grid array. So, when I change each of these, it basically changes those assembly variants. And then let me just go ahead and open up our ActiveBOM document here. I'll take a few seconds to open up. And when we go to ActiveBOM, it's going to immediately go out to the component cloud and get all that current information. So really what I want to show here as we're talking about variants is we see, in the case of this design, we have our blue LEDs here, okay? And if I use the no variations, you see the blue LEDs disappear from the bill of materials, and the red and the green appear. And your pricing information and everything would be updated based on that variant. The same thing with the the FPGA, BGA memory, and the alternative one. So I just wanted to get across when we're talking about the variants that it is holistic in its makeup. It's propagates through all of the areas. Now, if I wanted to change variant, let me just go ahead and show you how this is actually set up. To get to the variant manager, you just right-click on the variants category of the project panel, and we can see that we've got our information here. These are our variants on the columns. Blue LEDs, no FPGA RAM, FPGA RAM with BGA. And then you just scroll through the component instances. We see that there's a lot of components that aren't fitted here when you're not installing the FPGA RAM. You can see that as I scroll down further down here, for blue LEDs, it's going to bring in this part, which is the component that maps back to the component library, and you can just select those right from the library. And you can even search for those from here. You simply go in here and select. And then we have also for this is where we're swapping out the component for the RAM memory where we use the BGA. So this is how it's set up. So let me just go ahead and update one of these. Let's just say for the for the blue LEDs, we're gonna take out that debug connector. Let me find that guy. I think it's this P2. Yeah, it's P2. So let me go ahead and just bring this up, and we're going to say, not going to use an alternate part. We're just going to say we don't want that to be fitted anymore. So with no variations, this big debug connector is still here. But when we do change or choose the blue LEDs, the debug connector goes away. So that's how simple it is to set up a variant. And again, you know, you can set up all types of different variants, and this is a key to mitigating a lot of these part supply challenges that we can run into. Okay, the next thing I want to discuss is I want to go ahead and bring up my, let me go ahead and get back to 2D here. There we go. I want to go ahead and bring up my component library. And the component library is different than manufacturer part search because the component library is your component library on Altium 365. The components that you've curated, and you might have added your own information to that, you know, part numbers, internal part numbers, and things like that. So let me go ahead and bring up, we'll take a look at capacitors. And here's actually a good one right here at the top. We only have one part choice for this. This is a 2.2 microfarad capacitor. And let me just go ahead and show you the process of adding a part choice. You know, what I'm going to actually do is edit the component. Get this panel out of the way here. And we see we've got our component. It's bringing in our footprints and such. And you see the part choice area here. And I can simply add. Go ahead and choose capacitors. And I can just, you know, find the capacitor that closest meets. You know, I can also use this filtering, but I'm just going to key it in. You know, here's a great component here. Let me key in the right value. You can key in nanofarads, picofarads, whatever. It's going to translate it. And when you find the one that you want to add, you simply add it. And it becomes a part choice, and you can continue this process. You can add multiple part choices, and then you save the component, and then you release it, and you save that component to the server. And then we'll see later in the demonstration where this comes into play. I'm not going to save that to the server right now, but just wanted to go through that process. So that's one way to add part choices. Another way, like I said, you could go into the Explorer panel and add them there as well. When you spin a revision on your component, like I said, your designers will be notified essentially that there's an updated component that can be used. The other thing I want to do is I want to go ahead and jump into the web view of the workspace that I'm currently at. And this is coming up on my other screen. I'll move it over here. And this is the web view. And this is the same component library that I showed with the components panel. But I wanted to call your attention to this library health panel. This is another important aspect to utilize, again, to make sure you're on top of the supply chain issues. It'll give you an indication of whether you have problems with your library. Like in this case, we have risky life cycle states, we have stock issues. We have 189 parts that don't have part choices. Now, those parts might be eligible or maybe something that should be deleted or aren't used. If they are used in manufacturing, you certainly want part choices. And just an incredible amount of information here. It's like having a built-in parts auditor, on your team. It gives you all types of insight into what's going on there. So I did want to call your attention to the library health. Okay, and the final piece of Altium Designer I'm going to show is ActiveBOM. I'll go ahead and bring up that document. We already had it open from when we were showing it. I want to go through the problems that, I'm not necessarily going to go into a big drill down on how to use ActiveBOM. I think there are some other sessions, and it's been out for a while. I can, briefly show some things. I mean, I don't have any line numbers here right now, so I could decide to add those line numbers. There we go. We got the line numbers. And, we have all of the information. This comes right from the design, of course. There's a lot of connectivity between ActiveBOM and the rest of the design domains. It's really cool because, when you're really using this a lot of times, like right here, I see that I've got an obsolete part. It may be a while since I've been there. I don't even know where this is in the schematic. Well, I can just cross probe right from ActiveBOM, and it's going to bring up the schematic location as well as the PCB location. And there it is. So I did want to mention the cross probing. This particular part, like I said, it shows that it's obsolete. We'll try to fix that. The first thing I want to do, I want to call your attention to this right column. These are the BOM checks, and you can define, or not define, but you can set up these BOM checks. There's a variety of checks for a variety of issues that can hamper designs. I mean, you've got duplicate designators, duplicate values, no suppliers, no solutions, all this type of information that you can utilize to do these checks. And again, every time you open this, it goes and it refreshes that data. Okay, so this flag right here, well, the component revision is out of date. It's just like I was mentioning. There's obviously a new component revision. I'm going to see this right here in the BOM because my goal is to have all green check marks here. So what I can do, and this is really nice, is I can come in here and say, okay, I want to update that to the latest revision. Now, what that actually is doing is it's updating the components on the schematic. It's literally changing that. And then once it does its things, we've got that cleared out. We can see that our schematics have changed here to the left because it just did that. Okay, now this obsolete part here, that is a BAT54. What I'm going to do is I can edit the part change list here right now. Now this will be stored as part of ActiveBOM, not necessarily with the component. And I'm sure if that's not correct, somebody can chime in, but that's the way I've always seen it in when I'm doing it in ActiveBOM. But when I come into the part choice here, I'm just gonna, I know that that's a diode. As soon as this guy loads up here, I'm gonna bring up, get rid of this, bring up, okay, where are you? I'll go in this way. Discrete semiconductors. And I'll just search for BAT 54. And we'll see what we get here. You know, a lot of times there's so many different companies that make these various devices. And they usually have different suffixes that, you know, have to do primarily with packaging, but you would want to do a careful due diligence here. Go ahead and sort, and I can see, man, here's a good one. Nexperia, there's 776,000 in stock out there. And let me just go ahead and add this guy to the part choice. So again, you know, what I'm showing is what you might run into before you submit your design to be built. And then we're going to delete the previous ranking, or excuse me, we're actually going to keep that the way that it was. It was smart enough, and it fixed that problem. And then in a similar way, you know, we could do this, a 270 ohm resistor. I mean, it's straightforward to take care of that. You know, I do have some problems here. I have some obsolete memory here. There is some stock out there, but it's, you know, it's saying the life cycle is obsolete. So that's giving me more of a heads up. We could still build a couple of these boards. We'd probably need to find more of that. You know, this BOM is not without its issues. We have a couple of components here that we were notified, you know, where we did a last time buy of units, but they're actually end-of-life components. We're good for now in this example, but that's something that you'd wanna fix. So I'm running a little long on time. I could certainly fix that, but I did want to go through and show you a little bit of ActiveBOM. We added some part choices, and we'll go ahead and transfer back to the PowerPoint presentation and summarize. Well, I hope you found that demonstration useful. Let me go ahead and go into the summary, and we will wrap things up here. So basically in this section, or in this session, I reviewed, you know, electronic part supply chain fundamentals, how design architecture impacts part sourcing, how early planning for critical blocks and components can help. I reviewed some tactics for addressing part supply issues in current designs, you know, manufacturer part search panel, part choices. And we talked about the supply chain awareness that's literally propagates throughout the Altium Designer and Altium 365 workspace. And I've got a ActiveBOM screenshot there to the right. So to really summarize and wrap this up, you know, key recommended strategies going forward is, you know, improve your supply chain awareness throughout the entire design process. Purchasing parts and such used to be somebody else's issue. And in many cases, it is somebody else's issue even today. And a lot of designers, you know, are sort of apathetic about that. The thing is if your company can't ship their products, it's everybody's problem. And so you know, to borrow a phrase from another domain, if you see something, say something. If there is a part issue that you're identifying early stage design, you know other people are using that part, it's important to head that off at the pass, if you will, to be able to circumvent the issues that can cause. It's important to put BOM management on par with other domains. And when Altium Designer included, ActiveBOM, that's was embracing that. The idea of having a separate editor just for the BOM, which really is a design domain in and of itself. And you saw that in the demonstration where we were able to update that component from the BOM, actually change the design, because the three domains are very much related. So check BOM status, early, often, and throughout the design process. Again, I've hit it pretty hard today, but the idea of adding part choices to your components are key. That can save you time downstream. And the nice thing about ActiveBOM is it allows you to include, those multiple parts. So sometimes if you're doing your own kitting for your manufacturer, or even when the manufacturer is buying their own parts, they may only be able to get enough of one part for half of your run, and they might have to use two of the other parts. So it's great to give them those options. In the past, when I would submit a board and if that part wasn't available, I heard from the manufacturer. I had to jump through all kinds of hoops. This way, we've already pre-positioned known good substitutes that they can use so that you can get your boards back working properly. Again, establish contingency plans early for what I call risky parts. And parts that you really, really need that may be difficult to get in some cases. So that's it. I hope you found this session useful, and certainly want to wish all of you to have a very productive attendance here at Altium Live 2022. Take care now. Bye-bye.